This video will quickly talk about some measures of variability in a data set. The first and maybe the easiest to find is the range. To find the range, you just take the largest value in the set minus the smallest value in the set. Next is the interquartile range. This will be covered in more detail in the next section of this chapter, and this is the difference between the third quartile and the first quartile. Then we have the standard deviation. And this is actually a type of average of how far the data values are from the mean. And finally, the variance. The variance is just the square of the standard deviation. Or, if you want to think about it in the opposite way, the standard deviation is the square root of the variance. We're going to talk a little bit more about the standard deviation. So the formal definition is that it's a measure of variation of values about the mean. So in other words, how far on the average the different data values are from the mean. Now here's a formula to calculate the standard deviation, and this is the shortcut formula. This is a shortcut? Yikes! One of the main things I wanted to tell you in this video is not to try to memorize this formula. I won't make you use it on an exam anywhere. We will use technology instead to calculate the standard deviation unless you're just a glutton for punishment and you want to use this formula. Then go ahead. If you have a TI 83 or 84 calculator and you'd like to use it to find the mean and standard deviation, it's really pretty simple. There's another short video in Angel that shows you how to do that. And I would highly suggest that you watch that video if you don't already know how to find that on your TI calculator. The main thing I want you to understand about the standard deviation is not how to use that nasty formula on the last slide, but the different properties of the standard deviation. So first of all, again, it's a measure of the variation of values from the mean. One of the things that's important about the standard deviation is that the inclusion of outliers, or data values that are far away from all the others, can increase the value of the standard deviation very dramatically. The reason that we tend to use the standard deviation more than the variance is that the units of the standard deviation are the same as the units of the original data values. So if your original data was in dollars, then the units of your standard deviation are also in dollars. That makes it easier to understand than the variance. For example, with the variance, if your original data values were in dollars, then your variance would be in dollars squared, which is pretty hard to understand. So here's an example of comparing the standard deviations of two different sets. So we studied customer waiting times at two different branches of a bank, and they had different ways of having customers wait in line. At branch 1, customers waited in individual lines at 3 different teller windows. And at branch 2, all customers entered a single line and then went to whichever teller was available next. So here are some statistics done with StatCrunch for the two branches. And these show a variety of different statistics about the samples from the two branches. Notice here that the means are very close to being the same. This one's 5.301 and this one's 5.300. So the means are very close together. But then notice our different measures of variability. The variances are quite a bit different. The variance for branch 1 is much higher than for branch 2. The standard deviation for branch 1 is much higher than for branch 2. And if we go over here to the range, for branch 1 we have a range of 7.54. For branch 2 we only have a range of 3.49 approximately. And notice that if this didn't already give us the range, we could figure it out because they give us the minimum and maximum values in both of these displays. And if we wanted to, we could even find the interquartile range because we've got the first and third quartiles for each one. But the main point to understand here is that even though the means are the same, branch 1 has a lot more variability in the customer waiting times than branch 2 does. You can see that by looking at the standard deviation, since it's quite a bit bigger. You can also see it from looking at the range. And just if you look at the minimum and maximum values for each one, notice that at branch 1, a customer may wait any amount of time from 2 minutes up to almost 10 minutes. At branch 2, the range is much smaller, so some customers are only waiting 3.5 minutes, but the most any customer had to wait was approximately 7 minutes. What we're really looking at here is that for branch 2, the waiting times are much more consistent. Now, if we look at the histograms that are associated with these two data sets, again, we have branch 1, which was the one that had much more variability. And if you notice the histogram here, the data is spread out from 2 minutes up to almost 10 minutes. And there are a lot of data values sort of all along the way here. But for branch 2, the smallest we have here is about 3.5 minutes, and the largest value we have is about 7 minutes. And the data is much more bunched together. So it's not as variable, it's not as spread out. And that goes back to also what we saw with our range. The minimum and maximum for branch 2 were much closer together. The minimum and maximum values for branch 1 were much more spread apart. So this is what I want you to understand about the standard deviation, is that it gives us a measure of how much variation there is in the data. Larger standard deviation means that the data values are more spread out. And again, if we have what looks like might be an outlier, in this case we have possibly one or a few data values that are far apart from the others, then that's going to make the standard deviation even larger.